Hola, 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 sí. ¡Ey! Hola, hola, hola. Hola, hola, hola. 1, 2, sí. Hola, sí. ¡Ey!
A simple rocket requires... A command module allows us to control our vessel. As long as there is at least one command module on board, our rocket will be operational. This rocket will use a command pod, which can be manned by a Kerbal and is located in the pods category. Or multiple Kerbals. It all depends on the crew capacity of the part. For this lesson, we're going to make a small rocket, so we need a small command pod. Let's add this one.
Tú, pa'
Great!
dentro.
It doesn't look like much, but it's a promising start. The next thing our rocket needs is a fuel tank. Fuel, or propellant, is an expendable resource used to power our vessels. Without fuel, we won't be going anywhere, let alone space. Let's look at the small fuel tanks. How about that one? Rocketry Week. Notice the part is once again attached to your cursor. Now that's beginning to look like a rocket. Well, almost. We need an engine. Here at the KSP, we have 4 different types of engines: launcher, sustainer, orbital, and deep space engines. Now let's add the sustainer engine to the fuel tank. Excellent! Our rocket is looking pretty great. We just need one final touch. As is, our rocket can absolutely take flight, but if we want our pilot to survive our one Kerbal rocket doesn't weigh much, so we only need an extra small parachute. Now, congratulations! You've just built a rocket. Are you sure you haven't done this before?
Pues sí, lo he hecho before. Ahora se ve bien, ¿no? Yo creo que sí. Cuando construyas cohetes querrás ver tus diseños desde otros ángulos. Así que vamos a aprender
First,
cómo ver.
nice. Now let's zoom the Great. Now let's pan the camera up and down. You can also focus your camera at a specific part. If you want to view your rocket from the top, front, or sides, switch to blueprint mode. If you ever get lost in the VAB, you can always reset the camera. Nice. Now you can get at those hard-to-reach parts of your rocket. Let's move this rocket to a launch pad. Welcome to the launch pad. Today you'll be flying straight up. Your rocket should do fine without any steering inputs, but if things get out of line somehow, feel free to intervene.
¡Oh! Vamos. Vamos.
You've cleared the launch tower and your flight is underway. Let's learn about staging. Rockets are constructed in sections called stages. Each stage is designed for a different part of a mission. When a stage completes its job, it's dropped to shed weight. On your right, you'll find the staging stack. It displays all of the functions contained in each stage. Every time you select the Go button, you'll activate a new stage, starting from the bottom of the... Each stage's fuel supply is shown on a bar next to the stage. Your active stage, Stage 1, still has a little fuel in it. When it goes dry, you'll drop that stage by selecting Go. Your first stage is out of fuel, and all it is doing is slowing you down. To drop that weight, you're going to activate your... Ready? Hit Go to lose that mass.
¿Hay alguien dentro? ¡Hey! ¡Hola!
Congratulations! You're nearly to space, and your next set of fuel tanks are empty. Now is a good time to drop them. Activate the next stage to separate those tanks. Your capsule will now continue coasting up. All that's left to do is gaze back down at Kerbin and wonder if you remembered to lock your car. Nice work!
Bueno, de momento el tutorial está bien, facilito.
Your capsule has a lot of momentum. If you're curious how high up you are, take a look at your altimeter. You're so high that you can see the curve of the horizon. Rocketry involves a lot of waiting between the cool explosions. You can speed up time by selecting the time warp controls at the bottom of your screen. Check out your altimeter. You're about to start falling back down. Let's slow down and enjoy the view. Great job. You're now a master of time. Try not to use this new power for evil. What goes up must come. If you deploy your parachute too early, it'll be torn off. If you deploy it too late, you'll do some unplanned underground exploration. The sweet spot for Kerbin is between 20,000 and 2,000 meters. Okay, you're low enough to activate the final stage that contains your parachute. Hit Go to pop your chute. Nice work. The parachute will trail your capsule for a bit without fully opening. Once you've slowed down enough, it'll open all the way by itself. Your parachute is now fully deployed and slowing the capsule to a safe velocity. Congratulations! If this were real, you'd find celebratory snacks in the VAB kitchen. What goes up must come down. If you deploy your parachute too early, okay, hit Go to pop your chute. Nice work. The parachute will trail your capsule for a bit without fully opening. Once you've slowed down, your parachute is now fully deployed and slowing the capsule to a safe velocity. Congratulations! If this were real, you'd find celebratory snacks in the VAB kitchen.
Finalizar tutorial. Aquí ya tengo todas las piezas desbloqueadas. Quizá el modo historia lo meterán más tarde o algo así. La luna. Oh. Ojo. Era demasiado grande, ¿no? Hay ya como varios vehículos hechos. Bueno, voy a seguir con el tutorial.
Missing the ground. If you want to visit space for more than a couple of minutes, you'll need to get to orbit. An object is in orbit when it's moving sideways so quickly that even as gravity causes it to fall, it keeps missing the ground. As long as that object isn't slowed down by anything, it follows the same path every time it goes around the body it's orbiting. Forever. If that object is a Kerbal, it is recommended that they bring lots of snacks. So since your goal is to move horizontally at a high speed, why not launch sideways? On Kerbin, the atmosphere is like a thick soup. You waste a lot of fuel trying to fly through it horizontally. By launching vertically, you cut through the thickest part of the atmosphere as quick as possible. Most orbital rockets begin tilting toward the horizon soon after they leave the launch pad. This maneuver, called a gravity turn, uses the planet's gravity to turn the ship and reduces the amount of fuel needed to achieve a stable orbit. When launching near the equator, your gravity turns should point toward the east, since your vehicle gets a free boost from the planet's rotation. Thanks, planet! Once a vehicle is moving quickly enough that its arc will take it above the atmosphere, it shuts down its engines and coasts to space. Once it nears the top of that arc, the vehicle needs to fire its engines a second time to keep itself from falling back down to the planet. Doing this turns that arc into a nice big circle. Congratulations! You've missed the ground. When you're making a rocket, it's often easiest to work top to bottom, tailoring each stage to carry the weight of everything above it. Anytime we intend to drop an empty stage after using all of its fuel, add that decoupler to the bottom. We need to attach a larger, more powerful lower stage to the bottom of your rocket. To keep things simple, I've whipped up a new lower stage in another workspace. You can bring saved vehicles and other sub-assemblies. Out in the real world, this list would show all of your saved workspaces. Here in the simulator, now that the lower stage has been merged into your current workspace, perfect! Merging is a very powerful tool. Anytime you want to reuse a particular booster, lander, or other element from an existing rocket, merging saves you the hassle of making the same thing over and over. Space rockets sometimes need an extra boost. In a rare case of rocket scientists naming something well, these additional rocket engines are called boosters. Boosters are attached to the sides of a vehicle to keep them out of the way of the main engines. Solid fuel rockets make great boosters. They produce a We'll start by attaching 4 radial decouplers that will eject the spent boosters when they're empty. To make sure that these decouplers are evenly spaced and aligned with one another, you'll be using the symmetry tool. Great! Now when you place a part on one side of your rocket, 3 more evenly spaced. Good! Now attach it. Perfect! Now you've got 4 radial decouplers exactly where. Let's attach those solid fuel boosters. Since you're still in 4x symmetry mode, simply attach this booster to one of the decouplers you just. Great job! You've finished your orbital rocket. You can symmetrically place up to 8 parts at once, a feat that could until now only be achieved by certain sea creatures.
Está bien. Parece más saludable con el jugador que el primero. Bueno, es el tutorial y además parece que en el Early Access este está todo disponible, que no hay como un modo historia en el que vas desbloqueando cosas. Como que ya está todo. Supongo que pondrá un modo historia más adelante.
Nobody wants to start out their flight by popping their parachute, right? Most parts that can be staged are automatically assigned to stages. The staging order begins at the bottom of the staging stack. You want your boosters and main engine to fire together for maximum thrust. The solid fuel boosters are currently in the second stage. If we don't change anything, the boosters will ignite late and detach themselves at the same time. This would be embarrassing for everybody, so let's move the boosters down. Your solid fuel boosters burn very hard and very fast, so they will run out of fuel first. Even though your main engine and boosters will activate at the same time, you want to drop the empty boosters before you drop your main engine. You'll add a new stage above stage 1 to do one. Now move all 4 radial decouplers from stage 4 to your new. All done. Your remaining stages are set up so that stage 4 will activate your orbital stage's engine. Stage 5 will detach the orbital stage's fuel tank when it's empty. And stage 6 will deploy your landing parachute. Thanks to you. All right, we're ready to light this candle. In this flight, you're going all the way to orbit. Before we begin, let's talk about the nav ball. The nav ball shows your vehicle's orientation relative to the horizon. The blue half of the ball represents the sky, and the brown half represents the ground. The level indicator at the center shows your vehicle's orientation. When you turn, the ball turns. When you roll, the ball rolls. Assuming you want your rocket pointed at the sky, you'll want to see lots of blue on the nav ball. If you get confused, remember this rhyme. If the nav ball's brown, you're going down. At launch, you want all your engines at maximum thrust, which means you need to set your throttle at... You can see your main throttle here. Left, your fuel levels are visible within the staging stack. Right now, you can see that your main engine and 4 boosters are all topped off and ready to rumble. It's time to go. At the start, all you need to do is fly straight up. I'll check back in with you once those boosters are empty. Good luck! All right, solid fuel boosters are empty. It's time to start your gravity turn. A gravity turn uses the pull of the planet's gravity to help bend your vertical ascent into a horizontal arc. It's the first step to entering orbit. For our first flight to orbit, we're going to start our gravity turn up to where the air is thin, at an altitude of around 10,000 meters. To show you where to aim your rocket, first, we need to get to 10,000 meters. You're going to yaw towards the east so that the target marker is in the center of the nav ball. Your vessel and nav ball should look like this example video if you're performing the gravity turn correctly. Wait a minute, your current stage's fuel is empty. Let's drop it and activate your deep space. Great job! Your rocket is on its way to orbit. As you gain experience, you can make your gravity turns more efficient by starting to tilt your rocket soon after liftoff. Adjusting course with a series of small corrections instead of one big one will leave you with a lot more fuel when you get to orbit. Turning immediately after launch requires a very stable rocket. So if you ever have trouble keeping the pointy end up, you can try the simplified wait and turn method we use today. Right now, we're on a ballistic trajectory. If no further adjustments are made, your rocket will eventually fall back down to the ground. When planning and executing orbital maneuvers, the blue arc passing through your vehicle is its current trajectory, the path your rocket will follow if you don't touch the controls anymore. Let's break that down a little more. The top of your arc has a helpful tag in map view. It's called the apoapsis, abbreviated as AP. You're going to max out your throttle before you pass this point. We're paused at just before the apoapsis. You're all lined up and ready to go. The next step is to go max throttle. Once your trajectory reaches all the way around the planet, you'll see another marker on your orbit. This is the periapsis, or PE, the lowest point in your orbit. It'll always live on the opposite side of your orbit from the apoapsis, or highest point. By burning prograde near your apoapsis, you increase the altitude of your periapsis, the lowest point on your orbit. Here's the most important thing to remember about setting up an orbit above an atmosphere. Your periapsis must be higher than the atmosphere, or your rocket will start to slow down every time it dips into the upper atmosphere. Okay, your orbit is fully out of the atmosphere. Cut the throttle. You did it! You're in orbit! This is when I've usually...
Soy el mejor. Voy a conquistar el espacio.
Right now, we're on a ballistic trajectory. When planning and executing orbital maneuvers, you'll want to switch to map view, where you can see every part of your current trajectory.
Vale, ya he hecho 2 tutoriales de los 4. Voy a abrigarme que tengo un poco de frío y vuelvo. Let's go.
Orbits are weird. Remember your orbiting baseball? What if you wanted to make its orbit higher? Well, it's a baseball, so grab your bat and try to hit the ball to a higher orbit. Your first thought might be to try to deflect the ball upwards. Unfortunately, hitting the ball upward bends its orbit so that it hits the ground before it can return to you. What you need to do is hit the ball in the direction it's already moving, adding to its already high velocity. Now that you've sped the ball up, why isn't it flying any higher? It just keeps whizzing by at the same height it always did. After all, I said that making it go faster would make it go higher. What gives? The ball is actually going higher, but it's going higher on the opposite side of the planet from where you're standing. You've raised its orbit, and you've learned the first lesson of orbital maneuvering. Your actions affect the opposite side of your orbit. Weird, huh? So your ball is moving faster, but it's still passing you at the same height. How do you get its orbit higher on this side of the planet? Now that you know how changes in velocity affect the other side of your orbit, you've got all you need. By adding velocity to the ball at the highest point in its orbit, you raise the lowest point in its orbit and make it circular again. equatorial orbit is good, but if you want to travel beyond Kerbin, you will need to manipulate your orbit. Let's start with something simple. Remember how you circularized your orbit by increasing your forward velocity? To raise your orbit, you'll just do more of the same. It's time to burn program. Now that we're pointed the right way, we can increase the throttle and watch our orbit expand. Ooh, cut the throttle. If you overdo it, nice. That maneuver raised our orbit on the other side of Kerbin. So we will, like I said earlier, the highest point of our orbit is called the apoapsis. The lowest point of our orbit is known as the periapsis. By default, your camera is focused on your vessel. So if you can't see either of these points, adjust your camera. Scroll the middle mouse wheel to zoom in and out. Double-click an object to center your camera. Excellent! You can time warp to any position on your trajectory by selecting a point on your vehicle's current path, and then selecting Time Warp to Point.
Aquí me he perdido. Acelerar el tiempo hasta el punto. No me deja seleccionar nada.
An equatorial orbit is good, but if you want... Remember how you circularized your orbit by increasing your forward velocity? To raise your orbit, now that we're pointed the right way, we can increase the throttle and watch our orbit expand. Ooh, cut the throttle. Nice! That maneuver raised our orbit on the other side of Kerbin, so we will enter high orbit there. Waiting to reach a specific point can be as eventful as watching the neon stripes on your rover dry. The paint job will be worth it, but isn't it better to rush to the end? Skip ahead to the good Like I said earlier, the highest point of our orbit is called the Scroll the middle mouse wheel to zoom in and out. Double-click an object to center your camera on it. Click. Excellent! You can time warp to any position on your trajectory by selecting a point on your vehicle's current path, and then select... Now you're way up in the sky, so high that if you circularize your orbit now, you'll be in high orbit. Wow, the black starry void looks so small from here.
My dream is to fly over the rainbow so high.
From command pods to space probe cores, a lot of critical rocket parts use electric charge. You'll want to design your rocket so it can generate and store EC.
Qué chulo. Qué piezas más chulas.
Most rocket engines generate electric charge while active, but we'll still need a way to keep our batteries full while coasting between maneuvers.
Qué chulada. Pues tendrá que apuntar al sol, ¿no? Así no le dan mucho.
Solar panels convert Kerbal's light into EC for our rockets. Small solar panels can just be placed. Just kidding. There's a handy button that opens all of them with a single click. Give it a try. Great! The solar panels are now extended.
Acciones de nave.
Light tracking solar panels only rotate on one axis, so we may need to reorient our ship to point them fully at the sun. Let's make sure the panels are getting direct sunlight by rolling our ship a little bit.
Ahora sí, eh.
Excellent. The solar panels are soaking up all of those sweet photons and giving our rockets some much-needed EC. You can see the status of any solar panel within the part manager in the electrical parts menu. You can either access the app directly by clicking the app button, or you can right-click a part to directly access it in the part manager.
Aquí te dice el porcentaje de exposición. Está bien eso también.
Getting EC is one thing, and storing it is another. Most command pods have a small battery, but many missions will call for additional EC storage.
Va a chocar.
When we're traveling far from the sun or going to the dark side of a planet, more batteries means more peace of mind.
Habrá reactores de fusión nuclear en miniatura. Para no tener que llevar nada de eso. Ojalá.
At some point, the crew will run out of snacks. Did you know a Kerbal is 99.9% more likely to crash when hungry? That's when it's time to head back down to Kerbin, a planet known for its plentiful snack options. Remember how we burned prograde to raise our orbit? To lower, now flip retrograde, the opposite direction to our rocket's movement. All right, the rocket is aligned to retrograde. Increase the throttle and burn until our trajectory. As we decelerate, watch what's happening to our periapsis. Once it enters the atmosphere, this rocket is on a path back to the ground. Don't ease off the throttle yet, though. We're gonna keep burning until our trajectory intercepts the ground. This should give us a good idea. That's it. Let's stop our burn. Now that we're on a collision course with Kerbin, we need to turn that collision into something more survivable. This process of crashing without dying is called landing. Our upcoming stage will activate a decoupler, dropping the engine and exposing a very important heat shield. Why don't you do that now? Great! We're on our way down and our heat shield is exposed.
Hasta luego.
Have you ever wondered what a marshmallow feels like when it catches on fire? You're about to find out. At some point, the crew will run out of snacks. Did you know a Kerbal is... Remember how we burned prograde to raise...
Este ya lo he hecho. El último tutorial. Bien. Lo que no tiene pinta que vaya a haber misiones ni nada. Así que no las vamos a tener que inventar.
Orbital transfers. As you know, the faster you go, the higher your orbit gets. If you get moving fast enough, your orbit may cross the orbit of some other object, like a moon or a planet. The closest celestial body to Kerbin is the Mun. If you're looking for somewhere else to fly a rocket, the Mun is a good choice. The real trick to getting there is timing your departure so that the Mun captures your vehicle at its highest point. If you mistime your departure, you may miss the Mun entirely, which creates a lot of paperwork. Let's assume you've left at the right time and the Mun is there to meet you. As your vessel approaches the Mun, it enters a zone in which the Mun's gravitational influence on your orbit is stronger than Kerbin's. This zone is called the Mun's sphere of influence. You've had to go very quickly to escape Kerbin's gravity, much too fast for the Mun's low gravity to capture you. If you don't slow down, your vehicle will speed past the Mun and be flung farther into space. Remember what I said about paperwork? Once you're in the Mun's gravity well, the best way to slow down is to fire your engines backwards until your trajectory becomes a nice, stable orbit. Now you're a moon of the Mun! Ha! Our rocket is in orbit over Kerbin and ready to fly. The mission today is to, drumroll please, we're going to create a maneuver plan. Great! Now here's a new trick. We can select any object as a target in map view. Targeting gives us useful information and enables new tools. Once we've targeted a celestial body or other object in space, our maneuver will provide closest pass and plane angle information. This can be very helpful for meeting up with someone or something in space. Right now, our camera is following our vessel as it orbits Kerbin. Let's adjust our camera until we can see the Mun. Then, right-click to target it. We want to place this maneuver plan with two things in mind. First, the Mun is in motion. We can't aim our spacecraft where the Mun is right now. Instead, we have to aim where the Mun will be after our vehicle has coasted all the way from Kerbin. Second, remember how increasing velocity raises the opposite side of our orbit? Since we're placing this maneuver plan where we intend to start our burn, we should place it on the opposite side of Kerbin from where we intend to intercept the Mun. Placing a maneuver plan usually involves making a best guess, and then fiddling with the maneuver until you get an intercept. Fortunately, you've got a crack navig. Excellent! We've just created a maneuver plan. While we could find out if our departure timing is correct by just picking a direction and maxing the throttle, a maneuver plan tells us in advance how much delta V we'll need, how long we'll need to burn, and in what direction our vessel will need to point during the maneuver. Grab and pull the arrows to plan a burn along that direction. This maneuver is pretty simple. We want to burn prograde and expand our orbit. Nice! That maneuver event towards the end of your trajectory is exactly what we're looking for. It tells that if we execute this plan, we'll intercept the Mun. If a maneuver looks right, but we're not getting the intercept we expect, we can change the starting position of the maneuver by grabbing and dragging the middle of the maneuver plan along our orbit. It's very common to refine a maneuver plan by adjusting both the position of the maneuver and the direction of the planned burn.
No. Ahora.
If we don't want to maneuver at all, we can delete the plan, either by right-clicking the gizmo and selecting delete, or through the burn timer. Maneuvers are invaluable when leaving Kerbin. Feel free to come back and practice anytime.
Yo creo que íbamos a la luna.
We've got a maneuver plan that intercepts the Mun. Now we just need to execute that maneuver. Whenever we have a maneuver plan, a burn timer will appear. The timer shows you how much time is left until we need to execute the maneuver. I've paused the simulation for a moment, so this number won't count down quite yet. The timer also tells us how long we'll need to burn our engines at 100% throttle in order to complete the maneuver. Now let's take a look at the nav ball. Now your vehicle is properly oriented. And through the magic of SAS and more math than I'd like to admit, our vessel is properly oriented. We're still far from our planned burn, so let's speed things up.
Que no veo. Eso es un bug,
While we could rely on our reflexes to time warp at the perfect moment, unless departure burn, here we come. Great! We've exited just before our maneuver burn. Okay, get ready to hit the throttle. Watch the burn timer. We want to stop our burn once it reaches 0.
¿Cuál habrá buenos vídeos que me está ayudando con la tesis? Nada, Gabriel. ¿De qué estás haciendo la tesis? Me voy a pasar.
Great work! You've successfully executed a maneuver, and now we're on our way to the Mun.
A ver si llega.
It's going to take a while to reach the Mun, but don't let the wait fool you. We're now moving faster than any Kerbal has ever flown before. To orbit the Mun, we'll need to burn retrograde once we're inside its SOI, or sphere of influence. This will slow us down enough to keep us from being whipped into interplanetary space. Let's start by time warping until we're within the Mun's sphere of influence. That's the sphere within which the Mun is the primary gravitational influence on your vehicle. Let's get farewell, Kerbin. We'll miss you. Welcome to the Mun's sphere of influence. Let's slow down to normal time so we can create our cap. Did you notice that we've got a periapsis above the Mun, but no apoapsis? That's because we're going too fast to complete an orbit before sailing past the Mun. Don't worry, we have time to adjust. Our objective is to slow down enough so that both apoapsis and remember the rule of orbital opposites. In order to reduce our apoapsis, we need to slow down by burning backwards, or retrograde. This is a little like deorbiting over Kerbin, but we're going to stop burning before our trajectory meets Mun dust. Maneuver plan set. Next up, let's make sure if the maneuver is right and we're pointed in the right direction, now we need to time warp to the right position. And we're on our way. Almost there. When the countdown reaches 0, throttle up to start your capture burn.
¿Pero está apuntando donde tiene que apuntar o no? Uy, qué cosa más rara. ¿Por qué no está? Ahí está, qué susto. Uno, 0.
Keep burning until the burn timer reaches 0.
4, 3, 2.
Shut the engines now. We haven't. Fantastic. That was some fancy flying. Looks to me like you're about ready to try this for real.
Vale, pues ya hemos hecho todos los tutoriales. A ver ahora qué nos ofrece esto. Aquí ya no hay nada. Porque no hay modo historia, modo carrera, ni nada de esto, ¿no? Como en el otro. Un jugador. Campañas. No sé, raro, no hay misiones ni nada. Quizás eso al ser en Early Access simplemente pues tienes todas las piezas ahí desbloqueadas en plan modo sandbox y ya está. Empuje, masa, piezas, altura, anchura, longitud. Planificador de viaje. Para trazar un destino y cerciorarte de que tu vehículo puede llegar hasta ahí. Ah, qué bien. Esto no sé si lo tenía el primero. Viaje de ida y vuelta de Kerbal a... Pop. Duna. Una. Puede que no lo logres. Esto no sé cuál es la mejor forma de ponerlo, la verdad. Gestor de grupos. Gestor de Kerbals. Vale. Lo primero es... Estos son los favoritos. Que supongo que aquí ya te pondrán lo que necesitas para empezar. La nave tiene cápsula de mando, pero no paracaídas. Tenemos paracaídas aquí. Venga, vamos primero a hacer una vueltecita a Kerbin. Aquí en el 1 hay que ponerle como algo para protegerlo, ¿no? Antenas. Baterías, paneles solares, generadores. Ah, esto. Escudo térmico. Esto es lo que en teoría tiene que volver. Entonces, para que se quede en órbita... Bueno, no, espera. Porque esto hay que ponerle un separador. ¿Este era el de tutorial? No sé. Se enciende este motor, luego lo separamos. Se enciende el otro motor. Luego lo separamos. Y el paracaídas. Vamos a probar esto, a ver qué hace. Esto no sé si va a llegar a ningún sitio, ¿no? Es esto, ¿no? Aquí, APPE, Apoapsis Periapsis. AP 50-50. Voy a chocarme. Quizá para un motor, ¿no? Aquí no sé cuál es la altura mínima para salir de la atmósfera. No sé si me lo ha explicado en el tutorial. Quizá en la parte del de esto se explica, ¿no? Pero aquí hago una maniobra ahora. Es que creo que me queda corto. Vamos a darle chicha y a ver qué pasa. Me acabo de suscribir. Jesús. Muchas gracias, hombre. No hacía falta. Espero que no sea por esto y sea por los 200 vídeos que he hecho. Pero muchas gracias. Me voy a estampar. Cayendo ya. Estoy acelerando y estoy cayendo. ¿Sabes qué te digo? Freno. Giro. No, antes de girar. Vuelvo a girar. Tiro esto. Ahora sí que giro. Estampar en el mar. Bugueado, lo del tiempo. Me voy a estampar. Abro el paracaídas. a darme un baño. Uf, este buque es muy feo, ¿eh? Vale. ¡Toma! Pero se ha hundido. En el otro se quedaban flotando. ¿Qué pasa ahora si lo saco? ¿Se va a morir o qué? ¿No puede salir el muñeco? Míralo. ¡Oh! Ah, pues él sí que flota. ¡Oh, ¿puede nadar? No. ¿No bucea? ¿Puede bucear o no? Vamos. Vamos, bucea. Bueno, he roto el juego. ¡Ojo! Que tiene un jetpack. Ojo que tiene un jetpack. ¿Esto tiene combustible infinito? Vuelve a tu nave. Vuelve. Vuelve. ¡Oh! Se había cogido. Se había cogido. ¡Vamos! Ha entrado. ¡Qué bien! Ah, no, no ha entrado. Mierda. ¿Por qué se me ha puesto así la cámara? ¡Ah! 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 Bueno, voy a ver si lo puedo recuperar. Estación de seguimiento. Aquí era donde se recuperaban, ¿no? Las naves. Ah, mira, está cogido. ¿Por qué la cámara se ha vuelto loca? ¿Por qué está girando ahora? No. No, no, para. Se va a morir. Se va a morir. Para. ¿Cómo que pare? Que me estoy mareando hasta yo. ¿Qué hago? Creo que vamos a condecorar a este héroe. Ha sido el primero. Ah, mira, ya me deja recuperarlo. Qué susto. Menos mal. Qué mal rato, ¿eh? ¿Pero por qué sigue aquí? ¿Pero no lo había recogido ya? Nave. Destruir. Pues sale, ya no está. Bueno, le va a revertir el lanzamiento. Entiendo que eso hace que no haya muerto, ¿no? Está bien. Vale, ¿a dónde vamos? Va. No sé si intentar aterrizar en la luna es ya mucho, ¿no? A ver, estamos aquí. Aquí. Esto es lo que hay más cerca, ¿no? ¿Vale? La luna más cerca es esta, Muna. ¿Vale? Así que vamos a intentar ir ahí. Tengo que aprender cómo hacer colonias. O sea, lo primero que me gustaría hacer es una colonia aquí en la luna. Pero yo no sé si se puede todavía en esta versión del juego. Porque viendo las piezas... O sea, están las piezas típicas del Kerbal, pero no hay piezas en plan para crear colonias, ¿no? Puedo poner bombillas. Módulo de carga. Aquí hay más cosas. Y aquí hay motores bastante pros, ¿no? Qué raro esto, ¿no? Dios. Vaya bicharraco. Dios. Pedazo de cohetes. ¡Vamos! ¿Esto qué es? Esto es para ir por lo menos a Alpha Centauri, ¿eh? De hecho, antes me ha parecido ver como que ya había naves, ¿no? Aquí que te daban hechas. Vuelo seguro. Kerbal K1, prediseñado. Este cohete de segunda generación está diseñado para alcanzar la órbita de Kerbin con un mínimo esfuerzo. El centro modular KSS está prediseñado con el propósito de servir como centro de una gran estación espacial. ¡Wow! ¿Hacemos una estación espacial? Rover inquisitivo para explorar lugares de la Muna, Minmus o incluso Duna. Pulga saltarina. El cohete K2 está dirigido a alcanzar la Luna y regresar a casa de una pieza. Está guapo. Un gorrión teledirigido. Pues este, ¿no? Para ir a la Luna. Delta V de destino 5000 y tiene 6000. Y el gestor este... No, el informe del ingeniero que nos dice... 2,1 de relación empuje-peso, 111 toneladas, 20 metros de altura. Vale, tenemos una primera etapa que va a enchufar esto y esto. Luego los separa. Y luego tiene este cohete. Bueno, vamos a probar a ver. Ya hemos venido a jugar, ¿no? No ha pasado nada. Nadie ha visto nada. Todo bien. Dios. Pedazo de cohete. ¿Esto qué es? Stratus recodificado. Empieza a girar, venga, a girar. Pues en teoría, vale, si para eso, pero este debe seguir. Ay, se me ha olvidado mirar cuál era la altura de la atmósfera. Vale, y hay que clicar aquí, maniobra y estirar esto, ¿no? Ahí, más o menos. Aquí quizá me pasa uno. Más o menos. O sea, ahora mismo debería estar orbitando el planeta sin problemas. Vale, y antes me ha dicho que tengo que seleccionar esto como objetivo. Crear una maniobra. Y tengo que chocar con la luna. Creo que me queda un poco corto. Entonces, en teoría, si clicaba esto, lo podía mover. Algo así, ¿no? Quizá incluso un poquito antes. Se requiere 788 de delta V y tengo 2000, o sea que debería servir. Lo que no sé si luego para la vuelta me dará. Vale, aquí le damos a tope. Y ya está, ¿no? Debería chocar con la luna ahora. Vale, hemos conseguido nuestro objetivo. Y ahora lo que había que hacer era clicar aquí y ahora hay que frenar. Ay. ...239 delta V, tengo 1400, por lo tanto debería funcionar. ¡Conseguido! Estamos orbitando la luna. Bien. Este nivel del suelo es con respecto a la luna. No sé si lo cambia cuando automáticamente entras en la esfera esta de influencia de un cuerpo. Imagino que sí, ¿no? Porque si son 1000 kilómetros no será de la Tierra. O de Kerbin. Ué. Orbitando. Vale, y ahora si quiero volver... Establecer objetivo. Y aquí mismo una maniobra. No. No sé hacer cómo volver. ¿Alguien me ayuda? Esto es muy raro, ¿no? No sé, voy a probar esto, oye. ¡Ah! Ojo. Algo ha pasado, ¿eh? Porque si yo ahora aquí meto otra maniobra para frenar... No te pone información. Claro, aquí te pone el apoapsis y periapsis de la órbita en la que estás. Pero cuando estás haciendo una maniobra, estaría bien que te lo pusiese aquí también. Bueno, mientras haces la maniobra lo va poniendo. 30.000 me he pasado. ¡Ah! Hay muchos, bueno, algunas misiones que lo hacen. Pones el periapsis por debajo de la atmósfera y das muchas vueltas. Entonces cada vez que pasas por aquí te frena un poquito, te frena un poquito, te frena un poquito. Y así pues, sin gastar combustible, te va frenando. Pero ahora creo que me he pasado. Y me voy a estampar. ¿Dónde estoy? Estoy ya aquí dentro. No me había enterado. Vamos a separarnos. Y ahora ya estamos en la atmósfera y ya nos la vamos a pegar. Muy lentamente. qué es lo que queremos. Grande Tim Kerman, que se ha ido hasta la luna y ha vuelto. Mi mejor astronauta de momento, ¿eh? Esta sí que se ha quedado flotando. Métete. No voy a saliarla. Recuperar vehículo. Un aplauso para nuestro astronauta que ha ido hasta la luna y ha vuelto. Menudo héroe, la verdad. Pues muy bien. Bastante entretenido y divertido el juego. Creo que le voy a echar horitas. Y si os gusta, pues podemos hacer esto directos. Así pues no me aburro tanto solo. Y si la gente se anima, pues podemos charlar también un poquito durante el juego. Lo dejo aquí por ahora. Y nada. Nos vemos. Chau, chau.